All right, this is part 5, and this will definitely be the final video because I know I can get through these last few problems in just one video. So, question number 23, part A, it says 20% of the students were not, and I'm going to stress this, were not going to go to college. Okay, we've got a total senior class, right, 400 students. How many of those 400 were going to college? So here's the thing. 100% represents all the students in the high school in the senior class, right? So if 20% were not going to college, then 80% were. Okay, so 80% were going. So what we're going to do for this one is we're going to do percent times total equals part. So the percent is 80%, so that's going to turn into 0.80 or 0.80. Okay, and then total, right? Clearly we have total of 400 equals, and I'm going to use G for going because I can. All right, I think I have a calculator. I do. There we go. This is a definitely calculator question, so we're going to do 0.8 or 0.80 times 400. So 320. It gets rid of the calculator. There we go. Okay, we're going. And there's only one question here, so only one answer. 320 seniors were going to college. Okay, part B, if the price of the stock was $45 a share and it increased by 60%, what would be the price per share now? Okay, so this one is old plus or minus percent times old equals new. So we have the price of the stock, that's the old price, so that's the $45. It increased, so that's definitely adding, 60%, so that's going to be 0.6 or 0.60 times the old price, the original price, equals, I'll use N for new, and whoops, I wasn't meaning to do that, I was trying to grab the calculator back. Fling the screen. Okay, so this side is all numeric. It can go on a calculator. So let's get rid of that 320 from the last run. So 45 plus 0.6 times 45. All right, so now let's get back to pen here. The new price would be $72. Okay, get rid of the calculator again. All right, so the price was, increased by 60%. That's a heck of an increase. All right, last but not least here, we got question number 24. It's not even last, it's getting to the last part there. We have a quadratic inequality. We need to solve it. We've got the 0. That is great. I'm going to go ahead and factor the left side. So taking out a GCF of 2x, I've got x minus 2 left over. So then I'm going to set each factor equal to 0. So that's equal to 0. So we've got x equals 0 and x equals 2. So on a number line here, let's go ahead and fill in, I've got 0 and I've got 2. So I want to test that interval to see if it works, test the interval here, and I'm going to test the interval here. All right, so something less than 0, I'm immediately going to pick -1. So let's see, 2 times -1 squared minus 4 times -1, I want that to be less than or equal to 0. Let's see, -1 squared is 1, 1 times 2 is 2, -4 times -1 is be +4, 2 plus 4 is 6. Yeah, 6 isn't less than or equal to 0, so that's false. So I'm going to ignore then everything less than 0. I need a value between 1 and 2, or a 0 and 2. I was already saying the number I was picking. So the number between 0 and 2, I'm going to pick 1. So that's going to be 2 times 1 squared minus 4 times 1, less than or equal to 0. 1 squared is 1, 2 times 1 is 2, -4 times 1 is -4. So 2 minus 4 is -2 is less than or equal to 0. That is true. So on the number line then, I'm going to pick between my critical values. So 0 to 2, that tests true. And then one more test is going to be some number greater than 2. I'll pick a 3, keep my number small. So we're going to do 2 times 3 squared minus 4 times 3, less than or equal to 0. All right, so 3 squared is 9. 9 times 2 is 18. 4 times 3 is 12. And it was minus 12. So 18 minus 12 is going to be 6. 6 is less than or equal to 0. False statement. That is absolutely not less than or equal to 0. So after all this hard work, the only numbers that work are the values between 0 and 2. So let's go ahead and write that in interval notation. We do have an equal to part in the inequality. So we're going to go ahead and use brackets there for 0 to 2. And that's the final answer for number 24. Now we've got domain, range, and zeros for number 25. And I believe this is the last question. All right, so I want to find domain. So domain are my x values. So I've got 3, -5, 3, and 9. Now, 3 got repeated. Whoops, hold on. Too many threes. 3 got repeated here, and here is my x values. So I'm only going to write it one time. So let's see what I've got here. -5, 3, and then 9. Range, those are going to be my y values. So if I look at my y values, I've got 2, 3, -4, and 0. You don't have to write these in order. I do recommend it, though, just because it keeps it easy, especially if you're looking to compare things. And then zeros. The zeros are where the function is equal to 0 and function is equal to 0 right here. So that's going to be when x is equal to 9. One quick thing about this particular problem, not that it's asked for, but this is not a function. All right, so we'll throw back to some other stuff we've done. 3 here and 3 here, I mean the double x's, those did not map 1 to 1, so that is not a function. Again, not the question you were asked for, but I'll throw in a little extra at the end there. All right, so this concludes, I believe that's the last question. Yes, it is. All right. So, as always, please ask me if you have any questions or concerns, and I'll see you in the next video. That's not what I wanted. I wanted to, don't get the calculator out. Wow, go away. Make the calculator go away. Let's see if I make the video go away.